So we're looking at the normal and effective interest rates. Before now, we have been asked to calculate the future worth, the annual worth, or the present worth of an investment using a particular interest rate per year. So that interest rate we have been using is called the normal interest rate. But in a situation whereby we are told that the interest rate given is compounded more than once a year, if you want to calculate anything for that year, that interest rate that was given to you is not the interest rate they are to use for that year. That interest rate is only for the period of time that you were told that. For example, now if you're told that if you are told to find you are told to find that something was the interest rate of something is 12% per year compounded monthly. It means that this 12% is just for 1 month. I don't know if you understand. So that the interest rate 12% per year,
We are saying per year.
compounded monthly. Okay, the per that this interest rate 12% eh, is compounded every month. So
Okay.
for you to get the one to use for per year, you have to find the effective.
Okay.
Effective.
Okay.
So in this case now, the R now is the normal interest rate, while the M is the number of compounding period per year. In this case now, how many months do you have in a year? 12 months. If you put these values here, you now get the interest rate you have to use to solve, which is the effective interest rate.
Yeah.
So let's look at another example. We're told that another example is that the interest rate 12% per year compounded quarterly
Okay.
for quarterly. That this 12% is compounded every three months. In a year, we have 4 quarters. How do you go to that? This word quarter means 1/3. I mean 1/3 of 12, which will give us 1/4 of 12. Quarter means 4.
Okay, yeah.
1/4 of 12. It will give us what? 3. So, so in 12 months, we have 3, 3, 3, 3, 3. So that's why we have our M to be 4. Okay. If you are told biannually, means twice every year. So this one was confusing me, but if you do quarter means 4. If you do 1/4 of 12, you get 3. So it's compounded every three months. So in 12 months, we have 3 months, 4. So in this case now, our effective interest rate will put 1 plus 12%, that's 12 over 100 over 4. All raised to power 4 minus 1. Anything you get, that's the interest rate you use to solve that problem. So let's solve one example. I will not put your head. Yeah. So a person invests 25,000 for 15 years. A person invests 25,000 for 15 years at 8% interest rate compounded quarterly. this person, at time zero, he invested 25,000 and intend to keep this money for 15 years. Let's call it 5, then 15. So this year is long now. The bank are now compounding the interest for this person every quarter. Every quarter. We know that the interest rate here is 8% compounded quarterly. Let me read it again so this will capture it. Says that a person invests 25,000 for 15 years at 8% interest rate compounded quarterly. How much will the person, how much will it worth at the end of the 15th year? It means we should find the future given the present. We should find F given P, and F given P is equal to this. But since the interest rate is compounded quarterly, this 8% does not, is not the interest rate per year.
Yes.
It's the interest rate every 3 months. So for the I that we're going to use here is the effective interest rate. So in that case, we are going to find IE is equal to 1 plus this R is the normal interest rate, which is 8%.
Yes.
We do 8 over 100, we get 0.08 over M. M is the read your question elements, the
Number of compounding
period per year.
Yeah.
M is the number
Compounding period per year.
of compounding period per year. So how many times will you see a quarter in a year? 4 times. So our M is 4. This 4 and 4 minus 1. So let's punch this.
Punch.
Let's punch this. Is equal to 8.24%. So this is the value of the interest rate you are going to use here. So our F will now be equal to 25,000 1 plus 0.0824 is equal to 15. So let's find this.
It's 198.9.
819.8.9. So that's the answer. Do you understand? Another question.
Yeah, for consider total F is equal to
So let's look at another question.
P. A minute, please. This F is what?
Future what?
Future what that we're to find.
The person invested this money at an interest rate of 8% that is compounded quarterly, and intend to keep this money here for 15 years. They're asking you how much will this money worth in 15 years time. So we want to find the future worth of this present value.
Hence,
So that's why find F giving P. Find the future giving the present.
Are you going to pick 25,000 plus this one, or that 25,000 will be 1,100?
There's a formula.
From the formula.
The formula was developed using principal plus interest. That's the formula. It was using that method that they arrive at this formula. Just use it like this. Because it can't be doing, if you see it explained, it can't be doing principal plus interest. That's why you write with like compounding is very lengthy. This formula is this to get the answer. Just use the formula. Just that. Okay. Okay, look at this question. I see that a refinery wishes to install. Don't need to write. Don't need to write. A refinery wishes to install an air pollution control system in its facility. Okay. The system comprises of three types of equipment that involves capital investment, an annual recurring costs, as given in the table above. But assume a useful life of 10 years for each type of the equipment. And that the company wants a minimum return of 10% on its capital investment, which equipment is to be used. Now, this company wants to install an equipment, an air pollution control equipment in their facility. Then they have three options to pick from. And these three equipments, their useful life is 10. After 10 years, you're not supposed to use it again. You sell it. So that value that you get after selling it is called the salvage value. And equipment A, the initial cost, that's the investment, is 2 million naira. And every year you spend 10,000 on power, 5,000 on labor, maintenance, and all this. The company wants to know which equipment they are to pick. So we're going to represent each and every one of these things on the cash flow diagram. Remember that these expenses occur annually, and they want the equipment to be stay for 10 years. Means that if you sum this value and it becomes the annual sum, annual cost.
Okay.
Do you understand?
Yes, yes.
This is the initial investment at point zero. Power plus labor plus maintenance plus taxes, and this is going to be the total. If you sum everything, this is hypothetical. I just formed it. You understand? If you sum from year to year, you're supposed to get here. I just did this plus this plus this plus this. Okay, let's do this 15,000, 20,000, 23. 23,000. This is 5,000, 9,000, 14,000, 16,000. This is 7 plus 3, 10 plus 4, 14. 14 plus 7, 21. Abi? The equipment A, the initial cost, that's the cost of purchasing equipment A, is 2 million naira. And every year you spend 10,000 on power, you spend 5,000 on labor, you spend 5,000 on maintenance, you spend 3,000 on taxes and insurance. So the total annual cost for equipment A is 23,000, and the same applies for equipment B and C. And the company intends to operate the equipment for 10 years. And it's called the useful life of the equipment. That's the useful life. So the salvage value of equipment A is 50,000, equipment B is 100,000, and equipment C is, let's say, equipment is 4,000. So you want to know which equipment to pick. So you now draw this on a cash flow diagram. So for equipment A, this is zero. We invested 2 million naira. And this equipment, the useful life is 10 years. 1, 2, 3, 4, 7, 8, 9, 10. So every year you are spending 3,000. Do you understand? And so this is this you are buying this machine, you are spending money, it's going down.
What will be 2 million?
Yeah, 2 million. You bought this machine, it's expenditure, it's going down. You are spending 3,000 every year, the expenditure is going down. This service value is an income. So you come here and put, look, oh, you come here and put 50,000. So your goal now is to, you may be told to use present what cost, future what cost, or annual series cost. What do I mean? If you bring all these expenses to zero for equipment A, you keep the answer. You do for equipment B, you keep the answer. If for just equipment, you keep the answer. The lesser one is what you are going to what? Pick. Understand? So how do you do this now? You can either bring, if they ask you to use future cost, it means you should bring everything to the future. As you use present cost, bring everything to the present. If they ask you to use annual series, you either bring it to the future or present, then distribute it.
Okay, that's after you bring it to the present, you now find a given
Present. Or you take it to the future and find a using future. So this thing now is tricky. You know, look at these arrows, they are going down. This one is going, this one is going up. So this is plus and this is minus. So just call it this one and we'll call it the one more. Yeah. Let's look at it. So for this one now, let's take it everything to the future. To the future. So you say our f is equal to minus 2 million. We're finding the future, giving the present at an interest rate with our time at what? 10. This one now, we're going to find is minus 23,000. We're looking for the future, giving A. Do you understand? Plus 50,000. Because this one is already at this place. Okay? So it's already here. So there's no competition. It's not already here. So once you do this, you keep your answer. You do for everything two. You keep the answer. If for the total equipment, keep the answer. Since it's minus, the one that minus is lesser, what are going to pick? Do you understand? So,
okay, the one that has lesser value.
lesser value. So this is for if you are asked to take it to the future. If I don't take it to the present now, it will be minus 2 million, are we? Minus 23,000. Finding P, giving A, I, 10, plus 50,000. Finding P, giving F, 10.
Sorry. Why are we picking the lesser one?
If you bring these values here now, The lesser one means
Okay, the amount you are putting in
is lesser.
Okay.
If you take it here now, means that the man that you will lose.
Okay, you
Lose. You understand? If you get to the future now, the one that I will lose, I will lose.
Okay.
So you're going to pick. You're in the annual series now. The one that will give you the lesser amount to spend yearly.
Yeah. Now, sorry. This one now we are computing that 50,000.
Yeah.
It's not supposed to even be
50,000 is here now. I want to take it to the present.
Okay, so okay.
You understand? 2 million is already here. So you're not getting interest rates. Then I don't do that. You can say 2 million, find the present value, your end will be what? Zero. Zero. So you get zero. You get zero. You can see that a city plans a pipeline to transport water from a distant watershed area to the city. City anticipate that it will need to keep the water line in service indefinitely. You have to compute the capitalized cost, assuming 7% interest rate. This capitalized cost is the cost that will keep this pipeline running indefinitely. Indefinitely. The question is not even complete. Plans a pipeline to transport water from a distant watershed area to the city. The city anticipates it will need to keep the water line in service indefinitely. Compute the capitalized cost, assuming an interest rate of 7% and $8 million is spent every 70 years. Now, I want to know how much we are going to invest to keep this pipeline running indefinitely. But 78 million naira is spent every 70 years. Want to know how much we're going to keep aside to take care of these expenses that occurs every 70 years. It's called the capitalized cost. Capitalized cost. So the first thing to do, the formula for capitalized cost is, the formula is P is equal to A over the interest rate. A over the interest rate. So since this thing is periodic, it means that the annual cost per year will also be periodic. It means from 0 to 70, the amount I'm going to spend every year is 1, 2, to get 70 years will also be periodic. So we must find this A. Once we find this A, we now do A over I, we get the answer. So how do we do that? To find A now, how do you find A? You can say find A given future F. Let's find A given
564956.
564.
956.1.22.
So our capitalized cost P will be equal to 564,956. Divide by 0.07.
By
0.07.
8070.
807.
803.107.
So if you invest this money now, it will be able to yield 8 million every 70 years. Indefinitely. That's what this thing is talking about.
So why did we bring it to the, like, why did we do what's it called?
A given PRB.
Yes.
I think it's because we're trying to find the presence.
Okay.
We're trying to find the money that we should have
Okay, now.
to be able to take care of future expenses. Let me write the last question. So this one says a new computer will be used indefinitely. Find the equivalent value now if the system has an install cost of $150,000 and additional cost of $50,000 after 10 years. The annual maintenance cost is 5,000 for the first 4 years and 8,000 thereafter. In addition, it is expected to be there's expected to be a recurring major upgrade of 15,000 every 30 years. So we draw our cash flow with an initial installation cost, which is 157. $150,000. Now said there's 50,000 naira after 10 years. So this is our 1, 2, so let's say 9, 10. This is 50,000. Now said the annual maintenance cost is 5,000 for the first 4 years. So for the first 4 years, there is 5,000 annual savings. Annual savings. And 8,000 thereafter. That does not have end. So from 5, let's say there's 5. There's a uniform distance to infinity of 8,000. Do you understand? Then, in addition, it is expected to be a major recurring cost of 15,000 every 13 years. So if you have 13 years now, you spend 15,000. 20,000, 16,000 till infinity. Till infinity. So you want to find the equivalent value now. So you bring all this money to 0. So the first one is easy. So our P, just be 150,000. See, because we don't have up and down, I didn't bother about the sign. You get it? Yes, we bother about the sign. So this 5,000 now, it is an annual uniform series. We now find P given A. That's it, 5,000 How many years? 4 years.
4 years.
The next one now, there's an 8,000, there's an, there's an 8,000 annual expenses to infinity. So what do? So that you can bring it to the present as we did before. You bring it what to the present. Do you understand? So how do you bring it to the present? You do what? A over I. Okay? Do you get? Once you bring it to the present, we now take it to what? To 0. So we now do plus 8,000 over I. That value now we now take it now becomes our future, finding our present, giving future to be 4 years. Do you know it's 4 years? It is at 5, abi? Took it to 0. Abi? If you now count from it to 0, now you now get 4 years. That's how you get here. The next one now we have this 50,000 naira here that was spent after 10 years. We take it to the present as plus 50,000 bracket finding the present giving future for 10 years. For 10 years. So also there is an expenses that occurs every 13 years. Every 13 years. It means that there is an annual payment that is uniform for the first 13 years, also uniform for the second 13 years till infinity. So we're going to find that value. So we're going to find A giving P. Do you remember? If you find A, it's not a giving P, it's in the future. It's in the future. This one is in the future. So you know, I come in here. So we're going to find A giving F. Anything we get, look, remember that this is our 13. This is our 13. We want to find that annual money here. This is our 13. We want to find that money that occurs every year. So we're going to look for A giving F is in the future. We want to find 15,000 bracket finding A giving F for 13 years.
Yes.
Anything we get, we now say over I.
Okay.
So this now you get the answer. And that is all for today.
Thank you.